wondered how companies predict their sales, or how weather apps forecast the temperature? The secret sauce behind these predictions is something called regression. Welcome back to Knowledge Academy's YouTube channel, where we turn data science mysteries into clear, actionable insights. Today, we're unraveling the magic of regression in machine learning. Stay tuned, because by the end of this video, you'll be able to impress your friends with your predictive powers. All right, let's get started. So, what exactly is regression? In simple terms, regression is a statistical method used to examine the relationship between two or more variables. It helps us understand how the typical value of the dependent variable changes when one of the independent variables is varied. Imagine you want to predict your exam score based on the number of hours you study. Regression can help you figure out that relationship. Let's understand this term with some day-to-day examples. Suppose you're a data analyst at a retail company and you want to predict next month's sales based on advertising spending. You have historical data that shows how sales figures vary with different levels of advertising investment. Using regression analysis, you can create a model that predicts sales based on advertising spend. This model will help you understand if there's a strong relationship and how you can optimize your budget for maximum impact. Now, there are several types of regression, each suited for different kinds of data and analysis. The most common ones are: first is linear regression. This is the simplest form, where the relationship between variables is modeled as a straight line. It's great for data sets where the change between variables is constant. Next, polynomial regression. This is used when the data relationship is curvilinear. Instead of a straight line, the relationship is modeled as a polynomial. Lastly, we have ridge and lasso regression. These are regularization techniques used to prevent overfitting by adding a penalty to the coefficients. Let's take a closer look at each type with some examples and graphs. First up is linear regression. Imagine you want to predict the height of a person based on their age. You collect data and plot it on a graph, with age on the x-axis and height on the y-axis. The straight line you see is the regression line. It summarizes the relationship between age and height. The equation of this line is usually written as y equal to a plus bx, where y is the dependent variable, x is the independent variable, a is the intercept, and w is the slope. The slope tells us how much u changes for unit change in x. Next, let's talk about polynomial regression. Sometimes, the relationship between variables isn't a straight line. For example, let's say you're modeling the growth of a plant over time. Early on, the plant grows slowly, then it speeds up, and finally, it slows down again as it matures. In this case, a polynomial regression would be more appropriate. The equation might look something like this, where the additional term cx squared allows the curve to fit the data more accurately. Lastly, we have ridge and lasso regression, which are used to prevent overfitting. Overfitting happens when our model is too complex and fits the training data too well, but performs poorly on new, unseen data. Ridge regression adds a penalty term to the cost function proportional to the square of the coefficient values. Lasso regression adds a penalty equal to the absolute value of the magnitude of coefficients. These techniques help keep the model simple and generalizable. Regression is often represented graphically to make the relationship between variables easier to understand. The most common graphical representation is a scatter plot with a regression line. This line summarizes the relationship and can be used for predictions. Let's see how it looks. In this plot, each dot represents an observation from your dataset. The regression line shows the general trend and helps you predict future values. The closer the dots are to the line, the stronger the relationship between the variables. And there you have it, a comprehensive look into the world of regression. It's an incredibly powerful tool for anyone working with data. Whether you're predicting sales, forecasting weather, or even estimating the impact of a new policy, regression can help you make informed decisions. In the upcoming video, we will have an in-depth understanding of linear regression. Stay tuned and keep up the pace of learning. If you enjoyed this video, hit the like button and subscribe to our channel for more exciting and informative content. Don't forget to turn on notifications so you never miss an update.